All right. Well, like I said, everyone, welcome back. Today we're going to be talking about pre-processing. We're going to start focusing a little bit into how to work with data whenever we're utilizing something like pandas or NumPy and how data gets interpreted and how we're going to go ahead and utilize it to train our model in future lectures. So, with that said, let's do a quick recap of what we covered up to this point regarding learning models. We talked a little bit about how there's two kind of different branches of AI. There's large language learning models, and then there's classification learning models, where large languages are kind of like ChatGPT, and then classification learning models have something like binary and multi-classification, which is more the box that we're going to be unpacking throughout these couple of lectures. We then broke down how AI kind of, or deep learning, machine learning in general, breaks down images to turn them into decimal numbers, feed them through our AI, and then come out with some sort of evaluation or final prediction or probability that we can evaluate to be either true or false. That's kind of what we're seeing here in this funnel here on the right-hand side. So with that said, today we're going to be diving into how to grab this data and get it ready to actually feed it through this funnel of what will be represented as our learning model. Does anyone have any questions regarding what we covered over AI up to this point? This is all information that we covered on Monday. Yeah, I see something there about neural network videos really help break this down. That's awesome. Fantastic. That is definitely a good resource to have there from, is it Brown 3 something?
Three
Yeah.
blue, one brown. They got a lot of good videos.
Yes, Three Blue, One Brown. Their YouTube series regarding how does AI work is a very, very handy. All right. Awesome. So it doesn't seem like there are any questions in the Yankee questions channel either. There's nothing on the chat. So let's go ahead and push forward into how we're going to be working with data. Now, in this example, the data that we're working with is data that is being represented inside of an image. But today, instead of working with an image, we're going to be working with a more of like a scientific study one, right? Where we are collecting information regarding water, such as the pH, the hardness, solids, all of these things are called attributes, right? They are all attributes of water that are being evaluated and being assigned a numeric value. And then here we have something called the hat or the actual target that we are trying to accomplish. And it tells us that this is going to be either a zero or a one. Now we could come back down, read a little bit more about what this is doing and how the data usage happened. It even tells us where the data source is. This is from Kaggle. I shared this CSV file with everybody inside of the Yankee channel. But just in case you want to check out this website as well, I just shared it inside of Yankee questions. All right. So here's the actual source of the data set probability, and you can see that there's quite a bit, right? There's a lot of different inputs regarding this data, 3,277 of them. All right. So now, when we take a look at the data, it shows us a small sample table here at the bottom. And in the small sample table, it's showing us, hey, these are all decimal points that we're going to be working with. We'll eventually be turning them into tensors. And then here's our Boolean variable, either 0 or 1. Now, something really important to notice is we want to make sure we look at this charts because we want our data to be pretty well balanced. We want to make sure that we're not accounting for data that is, or we're not throwing into our model data that may be missing specific attributes. So if something, for example, if something, a couple of samples have no values in them, well, then we probably don't want to use those samples that have no values for the training phase, right? And then whenever we actually feed our AI with some actual values later on, well, then we don't necessarily have to worry about the null values because we could just evaluate those to be equal to 0, all right? But during the training phase, you do not want to feed null values into your model. Otherwise, it won't be able to learn properly. Now, another thing that we have to make sure we watch out for is skewed data, data that is not properly balanced between a certain numeric value. So here we can see that we have between 321 and 61,000, and all of our data is a little bit skewed to the left-hand side. So we have to make sure we kind of regulate this data set so that it stays with some sort of consistent values for those. And we'll go into what that's called here shortly. All right. And then finally, we want to make sure we have a balanced data during the training phase. If we continuously feed our model a overwhelming amount of false values, well, then our model is going to learn how to predict for false values a lot faster than it is going to learn how to predict for true values. So if you have an abundance of values that turn into false, you may want to either cut those out so that you have the same number of zeros as you have of ones, or what you can do is you can generate samples that will actually turn into ones so that you have the same amount of data during your training phase. So that's kind of the general things that we want to make sure we check while we're looking at this charts here that Kaggle has available for us. Does anyone have any questions over why those charts are important and why we should be kind of taking a look at our data set before we go through it? All right, so we've talked about consistency, we talked about the relevance, and then we've talked about efficiency as well. All right, let's go ahead and move into how to work with our data finally. So here on the left-hand side, we have the water potability CSV file. I've already installed it. It's within my application. I can utilize it. We're utilizing something like read CSV if I really wanted to, right? So if I want to come up here, I can say, hey, I want to import CSV, and then excuse me, and then I could go ahead and say, hey, with open, I want to open the water potability.csv file as file. And then from there, I can say, hey, I want to say csv.dictReader, either dictReader or reader, I guess, utilize reader, and then pass in the file. And then say for row in reader, print row. All right, so we execute this. Like this also works, and it gives me back some sort of data set or some sort of data framework. Let me actually just make this bigger so that we have it available for us. But it's not necessarily formatting it in a way that is going to work with my program in a friendly manner. So maybe there's an easier or more efficient way to set up this or work with data other than CSV. Can anybody think of a different tool that we can utilize for working with data other than CSV reader?
Uh, put it into tensors.
Awesome. So we can put them into tensors, definitely. But how do I use
Like
this CSV file to put it into tensors? Owen?
would one of those frame like NumPy or Pandas do
Awesome.
that for us instead of using the plain tools you have with Python?
That's great. Exactly. So we would actually utilize something like pandas to be able to grab all of this information. So here I am in my terminal with my virtual environment. I'm going to go ahead and pip install pandas. So now pandas has been installed finally. And in this next block of code, I'm going to import pandas as PD. And now what I can do is I can say, hey, I want to read my data and I want to utilize this using pandas. So I'm going to pass the read CSV, and that is going to aim to the water potability.csv file. And then I can call the data attribute. Well, now this is taking a while because we just installed pandas, so it's importing it. All right. And now we have a really nice data frame that we can work with. We can see there's 3,276 columns, and there is, or excuse me, rows, and there is 10 columns total with 9 attributes, and then our hat, right? Our actual label at the very end. 9 attributes, 1 label. Fantastic. Now this is, we can see that this is way easier than what I wrote above, right? If I try to break this down so that I have any sort of a similar level where I have some rows and columns and everything is broken down this way, I would probably have to utilize something like dict reader so that I have my key value pairs. I would have to number the values themselves for each individual row. And in order to compensate for missing values or to analyze my data overall, I would probably have to write a couple of different functions to iterate through this data set over and over and over again to be able to find information, which would just be very time consuming and very heavy on my program. So instead, we'll utilize pandas to interact with this data coming in from our CSV file in a much easier and friendlier manner. Does anyone have any questions regarding pandas and how we utilize pandas to open up the CSV file? Okay, fantastic. It doesn't seem like there are any questions, so we're going to go ahead and keep pushing forward in this case. So now let's start manipulating this data a little bit with pandas. I want to take a look at the different values that I can grab utilizing pandas. Well, if I do data header, or excuse me, if I utilize a header of said data, it's going to come back. So here's giving me a key error. Well, if instead of passing in a header, I pass in something like, hey, pH, and then I execute it, then it gives me back all of my values for pH. So it tells me, hey, the header of this column is pH. The length, which is how many rows there is 3,276. And the data type that I am working with is float 64. So up to 64 integers of accuracy. Okay, fantastic. So that's my header portion. We could switch this as well to where I can grab something like hardness. That would also work for hardness. And we'll go into how to grab multiple columns as well here shortly. All right. So now for grabbing multiple columns, we can utilize something like ilock. And for ilock, what we can do is we can break down which rows it is that we want. So for example, if I wanted row 35 and I execute this, well, it would give me specifically row 35 with all of the key value pairs that I need, right? So this is the values for row 35. And I can also utilize ilock to slice through a specific number of data. So I could go from 1 all the way up to 25. And by doing so, I'll generate a small data frame that will have the numbers 1 through 25 rows with all 9 attributes and their 1 label for each individual row. So these are all just separate methods that we can utilize for analyzing data or just grabbing specific data rows. Does anyone have any questions over how we can manipulate data utilizing pandas here. Oh, did this thing do it again? Yes, it did. Okay. All right. Okay. Awesome. We're back and ready to keep going. So it doesn't seem like there are any questions. So let's go ahead and continue moving forward then. The first issue we're going to fix is going to be compensating for all these null values. Now, there's a couple of different ways to do it. When you want to compensate for null values, you could either decide to utilize the average of that row or that entire column, like what would be the average, and then place that in there. You could also decide to just completely replace it with zeros, or you could decide, hey, if it has a null value, we're not going to utilize this data at all. But let's see what we can analyze regarding our data. So I want to go through my data and I want to check, hey, what is null? Oh, okay. A restart. All right. So when I run data is null, it tells me, hey, these are the all of the rows. And you can see that for the ones that are null, it's evaluating them to true. Now, this is useful, but it's not necessarily something very clear for me in order to make a decision of how I want to treat these null values depending on the amount that I have. I definitely don't want to iterate through all 3,276 rows to figure out how many of these rows have a true value in them. So there's probably an easier function that I can utilize to come up with that specific result. Again, we're going to analyze data is null, and then we're going to pass in the sum argument. Well, now when you execute this sum argument, it gives you a very clear that in pH, yeah, 491 that are null values. In sulfate, we have 781 that are null values. And in trihalomethanes, I'm not going to pretend like I said that correctly. We have 162 null values. So there's a quite a bit of null values that we can interact with or that we can see. All right, great. I'm able to finally identify how many null values we have. Now, sulfate is almost a third of the entire data set that I have. So that kind of makes me a little bit concerned because I know that if I just fill in those values for some, if I get rid of all the rows that have this sulfate value, I'm losing a third of my training data already to begin with. And I don't necessarily want that. So rather than removing null values, I think what I want to do is I want to replace these null values with some sort of mean or average. And instead of, as if we were to do this with regular Python, I would have had to write an algorithm that would iterate through every single row. And every time it found a blank, it would replace it with the mean. So first it would have to create a mean for each one of these columns. Once it has the mean, then I would have to iterate and replace all my null values. It would be a whole mess. But because we're utilizing pandas to interact with this through a data frame, there's actually a function that will do this for us. So what I can do is I can pass in data.mean. Let's take a look at what that does for us. If I go through data.mean, you can see that it populates a mean value for each one of my rows. And that's essentially what I want to use to replace all of the null values that are inside of my data frame. So now I have the values that I want to replace for null values. And I know how many null values are present within my data set. Great. Now, how do I fill them in? Well, finally, for filling them in, we can say data dot fill null values. So that's going to be NA. And well, this function takes in two separate arguments. One being, what is it that you want to replace it with? Well, I want to replace these null values with the mean for the respective column. And I want to replace it in place. I don't want some sort of offset or anything like that. All right, we're going to execute this. And once I execute this, we're going to see that nothing necessarily happened. Well, what I can take a look at now is my isNull function one more time and grab the sum so I can figure out how many null values are still within my data set. And now you can see that there's all nothing but zero values, right? So we come all the way up above here. We go, hey, is there null values in our area? Tells me, hey, yes, there is. Here's some true values. We do have some instances of null. I then grab the sum. We can see that we had 491 for pH, 781 for sulfate, and 162. We wanted to fill in these null values with the respective means. So we calculated the means for each column. And then we fill in those null values with the mean in the exact location where that null value was located. And now when we run data is null sum, there is no null values inside of my data set anymore. So I don't have to worry about null values throwing off my model when it's trying to learn how to make predictions correctly. All right, I'm gonna go ahead and take a quick pause here and open the floor for questions. Does anyone have any questions over how we are utilizing data frames, how we're replacing all of these null values, or how we got to the point that we are right now? Juan?
In the fill NA function, that data dot mean, what is that functioning as? It's just telling it the mean values that you want to use, and just anything that's null within those areas is what you want to fill.
Yes, so this will find any null values, and for the null value that it finds, or the wherever the null is located, it will grab the mean of said row and then place it in that location. Okay, great. Doesn't seem like there are any questions, so let's go ahead and keep moving here. The next thing that we have to talk about in regards to data is the regulating of data. Where's this at? Too far. There we go. So the regulating of data, what does that mean, right? This is called scaling or normalizing, and then standardizing. So essentially right now, all of our data that's coming in is coming in a way that kind of looks this way, right? We have a bunch of different data entry points. Some of them may spike, some of them may not even fall very far, and then maybe we have another spike, and so on. Right? That's kind of what our data entry looks like. And there you go. Now, when I go to train my model, I need to make sure that I account for skewed data. What exactly does that mean? Let me go ahead and pull this up here and do kind of a visual demonstration of what I would like to do, right? Rather than having data that can skew throughout my entire data set, I want data that will fall within essentially a left and right lateral limit. All right. I'm not necessarily going to dictate the numeric values that these left and right lateral limits are. Instead, what I want to do is I want to take a look at the majority of my data, where that falls, or the range in which that falls into. And once I have that range calculated, well, then I can start adjusting these values that fall outside of said range. Okay, now why would I want to do that? Well, I'm training a model to make predictions based upon probability. So every time I throw in some sort of data or some portion of data that is just way too skewed, or way too far to the left or right, whatever we want to call it, I may be training my model to account for very particular edge cases. And that's not what I want. I don't want it to worry about edge cases all the time. I want to just worry about, hey, this is not we want to worry about just the commonality. And by learning the commonality of our different edge case of our entire program, it will learn how to handle edge cases on its own. So what this will do when we go to standardize it, it's essentially going to grab this point here and it's going to bring it down so that instead of coming out of our skewed data, it would just fall right at the top lateral limit. And it would do that here as well. And it would do that here. And then this one falls within our limit. Down below, this would get cut as well so that it stays within our normalized data. And this one would as well. And that's essentially what would keep our data within our left and right lateral limits. Uh, all right. Sorry about that. I was answering a question here on the chat. Go ahead, Juan.
So would it change those values or would it just set temporary values in the meantime?
So it would actually change the values themselves. It wouldn't change the value within the data frame. We're going to see that we're going to utilize a function that returns a new set of values. And that's what would be standardized between these between this top and bottom lateral limits. All right. So let's take a look at how we're going to break this down. All right. So now we have something that we want to use for our data, for regulating our data. And when we take a look at our data file is essentially coming in. It has 9 attributes, which is the majority of our file here. And then it also contains our labels, which is our answers, what we want our model to evaluate information to. All right, so here's my attributes and labels. I want to regulate only my attributes and not my labels because my labels are values of 0 to 1. So there's no point for regulating that. That's quite literally my answer. Those should never be manipulated or touched. So I need to separate my data frame to have 2 separate data frames, one that is only holding labels and another that is only holding attributes. So I can regulate this information. Well, let's go into doing that, into separating our data set file. We're going to call this features and labels here. Right. So for our features and our labels, we're going to separate them by saying, hey, our features is going to be equal to data.drop. And we're going to drop our label row, which is the potability. And then we're just going to add this access is equal to 1. And what that's saying is, hey, I don't want you to reform our entire data shape. Don't worry about it. Just cut out this one row. And then our labels will be the entire column of potability. Well, now we can actually take a look at features. You'll see that it gives me my 9 columns, right? But it does not give me the 10th one. Now I have 3,276 by 9 columns. And we could also take a look at labels. You can see when that gets executed, it comes out again with 3,276, and it's only one specific column evaluating between zeros and ones. So I just successfully divided my file to work this way. Great. Well, now that I have my file broken into two separate layers, let me do this here. I want to take these attributes and I want to feed them through my column here. I want to feed them through this funnel so that at the end of this funnel, I can have a balance of standardized attributes. All right, so that's all we're doing here. We grabbed our data, we divided it into two separate files. Now I want to feed it through this funnel of standardization and come back with some standardized attributes. All right, so that's top level what we're doing. How do we do that in code? Well, in code, we're going to utilize a separate package here, and it comes from scikit-learn. Let me go ahead and open that up here. All right, so this is standard scalar. And what standard scalar is going to do is exactly this upper, top, and bottom lateral limits. It's going to squeeze all of our data so that we can actually work with it and have it standardized before we feed it into our model. Now we can read through this. There's a bunch of math that it does in the background for us so that we don't have to necessarily worry about hard coding this. It is useful to have an idea of how this works or what it's doing in the background. And you can also get a couple of different methods. This is going to return a data frame that will have different methods that we can interact with. So let's move into this portion of scikit-learn. I'm going to go over to the install portion. We can see here that it tells me, hey, you need to pip show scikit-learn. I think this is the one that we want, pip install -u. How am I run this one? All right, so then we're gonna run our pip show scikit-learn. Let me put this on the chat as well so that everybody has it available to them. And let's run it through VS Code now. So that pip show didn't work. Let me try this one here. All right, so it was the other command. That's why you trust your gut the first time and you don't second guess it. All right, and now we have scikit-learn installed inside of our machine or inside of our virtual environment. So let's standardize our data. In order to standardize my data, I'm going to say from sklearn dot preprocessing. I want to import standard scalar. And that will allow me to create an instance. You can see that's a capital S, so we know that that is a class. So I need to create an instance for it. All right, there we have our standard scalar. And now I can actually scale my features. So I can say, hey, scaled, or let's say standardize features. Someone has a mic. And we can make that equal to scalar dot fit transform. That's going to take our upper and bottom lateral limits and then squeeze everything. And then take a look at features. All right. Let me go ahead and do this. So here's features 1 through 5. It's returning a data frame. Now, this is not necessarily returning a data frame. We're going to see that here shortly. We're going to standardize our information. And now I want to take a look at our standardized features. Well, now we have a numpy array. And what this numpy array did is it took our 1 through 5 variables, right? And it turned into something that should look pretty familiar to us. What does this look like to everyone?
Looks like a tensor.
Exactly. So now we're working with tensors, right? Our data has now been manipulated to go from a data frame that we analyze with pandas to a numpy array that can easily be turned into a tensor. All right. So now all of our data has been standardized. We can see that we have this negative 3.07. Our numbers don't necessarily look exactly the same. This is all supposed to be that very first row. You can see that in that first row, we have 3.7. Well, that 3.7 turned into a negative 2. Then we have 129. That also turned into a negative 2 point something. So all of our data has been completely interpreted for us to be fitting between that upper and bottom limit and squeeze. Now, the representation is still going to be the same. There's a bunch of math that happens in the background to make sure that the representation of the data is the same. It's just falling between the correct limits in order to not confuse our models. All right, go ahead, Owen.
What was the thought process about doing the 1:5 when you were transforming that into a multi-dimensional array?
Are you speaking about this portion here?
Correct.
This is just slicing. All right, so up above, I wanted to show the data frame being sliced for the rows of 1 through 5. And down below, I wanted to show the array values for the indexes of 1 through 5.
Gotcha. Thank you.
Of course. All right, any other questions? Okay. If there aren't any other questions, let's go ahead and take a look at our next portion. So now we have some standardized data. What is it that I'm going to do with this standardized data, or why is it even important? Well, the standardized data can now get broken again. And what I want to do when I break this data is now I'm prepping to actually start doing some training with my model. And because I'm prepping to do some training with my model, there's a couple of things that I need to take into consideration. So for example, whenever we're learning a new subject, if something gets taught exactly the same way over and over again, and you don't necessarily understand that information, and every time you ask for help or for clarification, the instructor or the individual who's explaining it, they're just saying the information exactly the same way, verbatim, right off the book, right back to you. regardless of how many times that person says it, things are just not going to click, right? It's kind of like the definition of insanity, doing things over and over again and expecting a different result, right? It's not going to happen. Now, that's something to think about when it comes to training. Well, we want to randomize the data entry that goes into our model as we're training it so that it's being taught the same outcome in different ways. And that's going to allow our neural network to calculate good weights and biases and make better predictions. All right. So now we know that we need to have a data set for training that will be randomized. All right. So now this is a training for data, right? Well, what about when I want to actually find out if my model is making good predictions or not? Well, for that, I'm also going to need to break this up so that I can see evaluation data, which will also be randomized. Now, why would we randomize it? If I'm taking the same test over and over again, and after I take the test or the quiz, we do a review and I'm getting all the right answers, regardless whether I'm actually learning information or not, I am going to eventually memorize the correct answers. And when I take this quiz, I'll just say, well, I have no idea what I'm reading, but I know because we did the review so many times over the last 10 times that I failed, that this is the correct answer. That's exactly how the model would work as well. And we want to make sure that that doesn't happen. This is called overtraining your model. When you overtrain it, rather than actually making predictions, it's just memorizing information or memorizing the answers. And when it tries to make a prediction, it's going to make inaccurate predictions because it never learned how to make predictions correctly. So we're going to break our data both into training and evaluation. Now, when we do this, we want to actually set some sort of standard as well. Now, what I mean by that is I want to have my training data to be on average 80% of my data. And I want my evaluation data to be on average 20% of my training. All right, so we're going to have an 80-20 breakdown of training information with evaluation data. And at this point, we will actually throw in our labels as well. So the labels corresponding to this 80% will also be present. And the labels corresponding to this 20% will also be present. And that way we have our split of our training and evaluation data of 80 to 20%. All right, so here's the roadmap. All right, we get our data, we divide it into attributes and labels. We standardize it to get some standardized data, and then we break it into an 80-20 balance of labels and training data so that we can actually move into training our model. Does anyone have any questions over this concept? All right, doesn't seem like there are any questions, so let's go ahead and move forward now and actually put this into some code application. All right. So now we're going to create training and evaluation data. All right, so for training and evaluation data, we're going to have features and we're going to have labels. And the way we're going to create these features and labels, the easiest way to do it is we can grab something called training test split. And that comes from sklearn. So I'm going to go to sklearn, go into my model selection, and I want to import the train test split. So now this is a function that is going to take in our standardized features and all of our labels, and then we can specify how we want to randomize and have our test size be implemented. So I'm going to go ahead and open up train test split. Again, this is going to take in first argument, which will be all of my scaled features or my standardized features. The second argument being my labels, which I have divided as well. And that will make a pairs between them. So it's going to match each row to its corresponding label as well. And then finally, I want to have my test size. Well, we talked about it. We said we wanted 20%. So my test size would be of 0.2, which means that my training size would be of 0.8. And then finally, I want to randomize my data. So I can say I want to randomize my state in pairs of 42s. So every group of 42 is going to get randomized and turned into a randomized group. All right. Now, what this is going to return is it returns a tuple. This tuple will return features for training. It will return features for testing. This might be better if we do this. Training features, testing features. It will then return training labels and testing labels. So that's the way my data is going to come back. All right. So I'm going to get my labels and my testing and my features. I apologize. So now this is the tuple that it's returning. Well, I can just do some destructuring here and grab that information. So I'm going to do training features, testing features, training labels, and testing labels. I'm going to set that equal to my training test split. All right. That is all going to randomize my data. When I run this, we can see that runs successfully. And let's take a look at a couple of them. So I'm going to take a look at my training features. All right. There I can see I have a tensor of tensors, it looks like. No, I have one tensor, a one-dimensional tensor here that holds all of my features for 80% of my data. And I can take a look at my labels as well that are corresponding to it. When I run this, you can see that it returns between the values of 0 and 1. Now, the final step that I have to do is actually convert these to tensors. So I can say, hey, I want my training features to be equal to, I want my training labels to be equal to, and I want my testing features, and I want my testing labels. All of them to be equal to an actual PyTorch tensor, which I'll be creating here. So I'll say, hey, torch tensor. And these are going to take in either training or testing. The other commonality that we have is I want them all to have a D type of, or a data type of torch float 32. So I'm going to change my data type here. I'm going to set it to torch float 32. so that all of them are sharing the same data type. Now you'll notice that my labels in themselves, they're just solid numbers, while my features, they look like NumPy arrays. So for my labels specifically, I want to make sure that I change the way that they're being represented. So I'm going to utilize the view attribute here and set it to -1. -1 by 1. All right. So there's all the commonalities in between them. Now let's break them down. This should be my training features. This should be my training labels. We have our testing features. And then finally, we have our testing labels. And that will convert them all into actual PyTorch tensors. All right, so it looks like we have a bit of an error here. Could not determine the shape object type series. Interesting. Where's that at? Got it. So because we're working with a data frame, it's running into an issue. So I want to make sure that it gets interpreted as only the values. So I'm just going to grab the dot values attribute out of my labels. I apologize, everyone. Let me clean that up and then run this. All right, so it worked correctly. It's giving me a bit of a warning. To copy from a tensor, it is recommended to use. All right, awesome. Thank you for letting me know. So now, when we take a look at our code, if I take a look at my training features, you can see that we are now being represented by a PyTorch tensor. And if I take a look at my training labels, you'll see that that is also being represented by a PyTorch tensor, where all of my values are float integers 32s or float 32s. I now have all the same data type. Everything has been divided correctly. And now I can go ahead and move into the training phase of my model. All right. And that is it for our data pre-processing or being able to actually analyze data. Does anyone have any questions over any of the material that we covered today? I know today's a little dry, especially when we're messing with just numbers, but this will become handy, and you can utilize the same exact process to work with images in this afternoon. That easy. Everyone's good? Let's hear it.
Can you just side by side walk through with the TL draw and at least from the standardized attributes down to like the 80-20 split? I got pretty lost there
Absolutely.
in the code.
There you go. All right. Let me see. So here's where we standardize all of our information, and we came back with standardized features, right? So this is where we are currently located, right? So that's where we're currently located. Now, I want to make sure I create this 80-20 split with randomized data. So in order to do that, I use this train split function. And what this train split function did is I passed in both my features and labels. Notice that these are the standardized features and labels. And I told it that the test size would be of 0.2, which is 20%. This tells it that the training size by default is of 80%. And then I wanted to randomize my information. So I randomize it in groups of 42 rows.
What was the point of choosing 42?
You could definitely choose something smaller. 42 is just the standard. If you choose something smaller, it's just going to take longer to randomize and you'll have way more randomized data. Huh. If you choose a way bigger number, then the data may not be randomized enough and your model can become overtrained. So I would go anything 42 and less, unless for whatever reason you really want to go for a higher number. If you have that much data entry, you may be able to get away with like 64. Does that answer?
And by randomizing the data, you literally are within that mean value and those left and right lateral limits. You're randomizing just it's not just picking out data, it's actually randomizing it and making new data.
Got it. So that's not exactly what's going on. What we're doing when we randomize data is when it's creating this testing training split, rather than having all of our rows in the exact order that they came in, right? So rather than having row one being row one and then row two being row two, inside of those group of 42s, it grabs the rows and just changes their order.
Gotcha. So this is just for the case of there is a bunch of the same results and you don't want your models to be trained on or like take preference to these results, I'm assuming.
Yes. So we just want to make sure that it's grabbing information or being presented information in different manners every time, right? Because if I just keep feeding it the same exact info in the same exact format every time I'm training it, it's going to memorize the outcome rather than make predictions for the outcome. Does that answer your question, Owen?
I think so. You're still pulling from all that same data though, correct?
Yes, it's all still
Okay.
coming from standardized data.
Okay.
Yeah, I guess I think the way I think about it is just like you said, like if you keep giving something the same process over and over again, the same numbers, the same set of numbers, it's gonna say like, oh, okay, it's gonna just predict this when that's really not accurate. So you give it like a little bit over here, a little bit over here, random and stuff, then it can look for patterns within that randomized data, and then it can make actually accurate predictions. I don't know if that makes sense. I think that's kind of what you were getting at, Francisco. I'm not sure. I think I get it.
Uh, I think I've narrowed it down. So are you randomizing the rows or you randomizing the elements and how they're presented? Or is
The
it both?
rows, the
The
rows
rows.
being randomized, yes, not the actual data points that are being presented.
Cool. That answers my question. Thank you.
Okay, awesome. James?
Um, are there some contexts where you would want to change the data entirely, or like I'm surprised that just changing the rows would prevent it from not just like learning what the answer should be, not making predictions.
So I don't think you would ever want to manipulate the data yourself. You can generate some fake data, that would fall between like the averages that you've seen before, right? You can generate more data, but you don't want to change those data entry points. Specifically, let's say we're talking about this example, right? Or the data set that we're working with right now. If we are changing data entry points, then what we're essentially doing is we are changing the attributes for different values, right? If I were to put this 6.2, this gibberish, and switch it with this 3.17, well, now I'm saying that my pH is 6 point whatever, and that my chloramines are at 3.17, right? And I don't want to do that. I don't want to change those attributes because I'm feeding incorrect data. Instead, what I want is a volume of data, and that will give me enough randomized entries so that my model can actually learn. I mean, we have 3,000 entries, right? So we are not having a lack of data at this point. Does that answer your question, James?
Yeah, I was meaning more like generating new data, not just changing it myself, because I'm sure I would do it incorrectly or something. So yeah, I think that answers my question.
Okay, awesome. Juan?
This may be either really easy or really difficult question. What would be a practical use case for any of these binary models anyway? Because normally I've seen some of the people using APIs online, like YouTube and stuff, that are already doing some of this for you. So I was just wondering, like, why would I want to build a binary model to begin with?
Awesome. Yeah, that's a great question. So even those APIs that you're talking about, they have a binary model that's running through. One of the main things that I could think of is, on social media, there's like a sentiment analysis, right? So like we want to know if a post is appropriate or inappropriate. So what we do is we train a binary model that will evaluate this post is inappropriate, right? Because I don't want to hire somebody to sit there and read thousands upon thousands upon thousands of posts just so that they can randomly tell me, hey, this is inappropriate. Instead, every time a post is made, that post gets sent to Django, right? Django takes a look at the post, then it feeds it to our AI. The AI evaluates to be either true or false. And then from there, Django can either decide, hey, we're going to save this to a database or we're going to block this user. And then we could decide what kind of response that comes back into. But that would be more the practical application of the binary model. Does that answer your question, Juan?
Yes, thank you.
Of course. Owen?
Yeah. Would there ever be a case where you're loading in two different like CSV files to where, yes, it does perfectly line up? Say you loaded in, like you couldn't get every single, say sulfate wasn't in there, and but you did find a file that lined up perfectly with everything else, but it had sulfate in it. Would you just want to throw that sulfate as a column in this current CSV, or would you be able to load up both of those files linearly somehow? Like, what would be the easier answer for doing that, or would you not want to do that at all? You just want it one complete file.
Okay, so let's take this example, right? Let's say this is a bunch of different groups that go out there and test the water. And each time they went out there and tested the water, one group only worried about pH, one group only worried about one specific attribute, right? So nine different groups, they gave me nine CSV files, and they tell me, hey, these are all the attributes that you need. And then I have all the labels, but they're all matching, right? All of them belong to the correct body of water, and I don't have to worry about it. Okay, so in that scenario, what I would do is I would probably utilize pandas to open up all of the different data frames, and then I would combine all of those columns to just make one massive data frame inside of a Python script.
Cool. Yeah, I don't need to know how to do that right now. I was just curious.
Yeah,
Thinking,
of course.
'cause I was thinking like for weather, there's all these different, like everything's probably it's all linear in time. Like it's all certain times and certain days. So like if you're pulling from different weather like selection methods, how would you do that? So that answered my question.
Okay, awesome. Yeah, absolutely. No, there's a pretty large documentation in pandas. Unfortunately, we can't like do a deep dive in there. But I think a Google search or, even with the help of some other AI, we could probably get that moving as well. Awesome. Any other questions regarding what we covered today? All right. Doesn't seem like there are any other questions. Tomorrow we're going to be building our binary model all together. And then we're going to go into our training and what that looks like. So let me go ahead and stop our recording.